In this video, we're going to look at spatial competition, in particular the circular city or the Salop model. So there are four identical firms symmetrically located around a circular street. So we got firm A, firm B, firm C, firm D, all equal distance from one another. The street contains 160 uniformly distributed households. So there's 160 households around this circle. Each firm is 40 houses away from the next firm, so the distance between A and B is 40 households, between A and D 40 households, and so on. All four firms produce pizza at a marginal cost of $10, and each household demands one pizza per week. Customers incur transportation costs to buy pizza, which equals $1 for every house passed on the way to buy pizza. We want to determine the equilibrium price of pizza. So a customer who's located between firm A and B, so where the smiley face is, here's a customer located between A and B, will be indifferent between buying pizza from either firm if the following condition holds. So the price of pizza at firm A plus X, and X is just the distance from this smiley face, this person, to firm A. So that is the full economic price of buying pizza at firm A, the price plus the transportation cost. And to be indifferent, that would have to equal the price at firm B plus the distance to firm B. So the overall distance from firm A to firm B is 40. If this distance from the smiley face to firm A is X, then this distance from the smiley face to firm B will be 40 minus X. So as I said before, where X is the distance away from firm A in houses, and 40 minus X is the distance away in houses from firm B. So we're going to take this above condition here, and we're going to solve for X. So adding X to both sides, we get 2X, and then subtracting this price of firm A's pizza from both sides, we get this result, and then dividing through by 2. So just rewriting our last condition. And then an important point, because firm A also competes for customers between its location and firm D. So here's firm A. So it's going to compete with customers between A and B, and then A and D. Firm A's total demand is just going to be 2X. So we're going to multiply this above equation through by 2X. And if you do that, you get this result. So this will be the demand for firm A. Let Y, just for simplicity, equal 2X. So making that substitution, we have the demand for firm A. And now we're going to solve this demand equation. Basically, going to get the inverse demand, so we're going to solve for the price of firm A. So moving some things around, we have the price of firm A. So price of firm A, or the inverse demand. Next thing we'll do is we'll calculate total revenue, which is just price times quantity here. And so making a substitution in here for P subscript A. So in parentheses, just making that substitution. Multiplying through by Y, we have total revenue, and we'll get marginal revenue by taking a derivative of total revenue with respect to Y. We're going to set marginal revenue equal to marginal cost, and I'm going to solve for Y. Solving for Y, we get this result. Now we're going to plug it into the inverse demand. So where we see Y, we're going to plug in P divided by 2 plus 15. Doing that over here, making our substitution. Since it's minus Y, we're going to have a minus in front of the P divided by 2 and the minus in front of the 15. Simplifying a little bit. And the next step, because all firms are identical, each firm sells at the same price in equilibrium. So I'm just going to call P subscript A P star, and this P, I'm going to make that a P star. And now collecting the P star terms, we get an equilibrium price of $50. And taking this $50 and plugging it back into over here, we can get the demand of 40. Okay, I hope you found this video helpful.